This is Note-Taking Guide 3.6 for Math 1. Today we're going to talk about average rate of change. So the interesting thing about average rate of change is it's actually something we've already been doing throughout the years of math. We're just going to call it something different now. So look at this formula right here and see if you can remember what that formula actually stands for. When you look at that, y2 minus y1 over x2 minus x1, that's really just your slope formula. So we're going to call our average rate of change. We're going to use our slope formula to do that. The reason it's called average rate of change now is because we're going to be finding the average rate of change over a curve. So if you look at this, what we're going to be doing here is we're going to be saying, oh, I want to know the slope between here and here on my graph. So in order to find the slope between here and here in my graph, I'm going to use a line to approximate that. So the line between here and here. I'll find the slope of the line between here and here, and that will give me the average rate of change between those two spots on my graph, which is really approximating the slope of that curve. So what we're going to do today is just use that slope formula in order to find that average rate of change. So sometimes we're going to start with a table of values. So this says find the average rate of change using the table of values. And so what we're going to do here is we're just going to find the slope between two sets of points. So just pick any 2 points. It doesn't matter which one. These are your x's. These x's here, y is here. Our slope formula said y2 minus y1 over x2 minus x1. So we're just going to plug into our formula. This can be x in my first point, y in my first point, x in my second point, y in my second point. So when I substitute in here, I have y2, which is 10, minus y1, which is 2, over x2, which is 4, minus x1, which is 2. Then it's just simple arithmetic. You can plug that in your calculator the way it is and just let it spit out an answer to you. On the top, we get 8. On the bottom, we get 2. So 8 over 2 is 4. So if you're asked to find the average rate of change for the entire table of values, you can just pick 2 of them and find the average rate of change, the slope, okay? Sometimes though we get a little more specific because this time it says to find the average rate of change for the interval from -1 to 1. Anytime we're writing an interval, we're actually giving 2 x values. So how far left, how far right am I going to look at my values? So I have been given x equals -1, which is right here, and I've been given x equals 1, which is right here. So in order to find the average rate of change, I'm going to use those 2 ordered pairs in my slope formula. So my slope formula again is y2 minus y1 over x2 minus x1, and I'm just going to substitute in. So here's x in my first point, y in my first point, x in my second point, y in my second point, and I just plug in. So y2 is 1 minus y1, which is 1. x2 is 1 minus x1, which is -1. On the top here I get 0. On the bottom here I get 2. 0 over 2 is just 0. So my average rate of change between those 2 points on the graph is 0. What that means is that it's constant. It means that it didn't move up or down necessarily in between those 2 points. It's just straight across. Okay? All right, here's another example. It says, given the function f of x equals 3 to the x, find the average rate of change from f of 0 to f of 4. Now, if you remember, these are both x values. We substitute them in as x. In order to find the average rate of change, I need to have a y1 and a y2, an x2 and an x1. So I have an x1 and I have an x2, but I got to get their y values. So I'm going to substitute them in to that 3 to the x formula and get my values. So this one would be 3 to the 0, which is going to be 1. So my first ordered pair is when I put 0 in, I got 1 out. My second ordered pair, I'm going to put 4 in. So 3 to the 4th power is 81 because it's 3 times 3 times 3 times 3. So when I put 4 in, I got 81 out. and I'm going to sub those into my formula. So again, remember, this was my first x, my first y. This is my second x, my second y, and I'm going to plug them into the formula. So y2 minus y1 over x2 minus x1. So I get 80 divided by 4, which is going to be 20. So average rate of change, again, you just got to find two ordered pairs, an x1, a y1, an x2, and a y2 to substitute into that slope formula. All right, next one, what is the average rate of change between f of negative 4 equals negative 3 and f of 2 equals 10? So this is really nice because guess what they just gave me right here? They gave me ordered pairs. They gave me negative 4 or negative 3. And they gave me 2, 10. So they gave me my ordered pairs. All I have to do is sub them in. So x1, y1, x2, y2. We're going to substitute them in. So again, the formula is y2 minus y1 over x2 minus x1. And I substitute into that formula. So 10 minus negative 3 over 2 minus negative 4. 10 minus negative 3 is 13. 2 minus negative 4 is 6. So my slope doesn't reduce. It's just going to be 13 over 6. All right, this next one says use the graph to find the average rate of change. And it tells me only to find it over sections. So it says, what's the average rate of change for the given section of the graph? And it says section A to start out with. So here's section A from here to here. You guys, when I have a graph like this, the easiest way to find the average rate of change is to just count the slope. So if I start here and I end here, I went up 20, 40, 60, 80, and I went over 2. So I actually went up 80 over 2, and 80 over 2 is the number 40. So the average rate of change in that section of the graph is 40. Okay, we're going to do the same thing for section B now. I actually went up 0 and over 1. Well, 0 over 1 is just 0, so my average rate of change there is 0. It's constant, and you can see that on the graph. I didn't actually change at all. I stayed the same. And then section E right here, here's my average rate of change, or my slope section I'm looking at here. This is a negative slope. I actually go down all the way and then over this way. So my actual slope for that is down 120 and then over 2. So my average rate of change is a negative 60 when I plug that in my calculator. All right, the next one, find the average rate of change of the graph over the interval 1, 2. So this time I have to look at my graph myself and figure out my ordered pairs to substitute in. So it says from 1, which is here. So that ordered pair on my graph would be 1, and let's say we're up at 4. Then it says to go to 2. And right there at 2, I'm over 2 and I'm up 16. So I'm going to use those two ordered pairs to find my average rate of change. Again, that's y2. So here's x2, y2, x1, y1, 1. That's a 1. So y2 minus y1 over x2 minus x1, and then just let your calculator do the arithmetic there. That's 2 over 1, which just comes out as the number 2. All right, well, one last example here. A couple of different average rates of change here. But they gave me this graph, so it'll be nice. I can just count the slope. And I actually, on this last one, I could have just counted the slope if I wanted to. I could have counted my rise over my run. And I could have just reduced that fraction. So this time, let's see if we can use that rise over run. So we're looking from negative 8 on x to negative 5 on x. Those are both x values. So negative 8 on x is right here. Negative 5 on x is right here. We're going to count our slope from this point to this point. So how far did I rise and how far did I run? Well, it looks like I rose 1, 2, 3, 4, and I ran 1, 2, 3. I rose 4 and I ran 3. So I'm going to keep my slope as 4/3 on that one. This graph is kind of hard to see, so maybe I should zoom in this time. This time we're going from -3, which is right here, to -1, which is right here. So I've got to see my rise over my run. So how far did I rise? Well, I come from here all the way down to there. And then how far did I run? Well, it's from there to there. So if I start up here at 4 and I come down here to 2, -2, then I actually moved -6. And if I started over here at 3 and went to 1, then I actually moved 2. So my average rate of change for that interval is the number -3. And then the last one says, what's my average rate of change from 0? Right here to infinity. Well, how are you going to figure out your average rate of change that goes on forever? That one's just going to be undefined because we don't actually know how to figure out an average rate of change that goes forever. Thanks for watching, you guys. Good luck with your homework.